So, hey everyone, good evening and welcoming you all in the today's ML Study Jam program. So, before we start, let me know, are you worried about your technical skills in AI and ML? Yep. Don't worry, we got you covered in our ML Study Jam program, all necessary equipments we have, and it will be also help for those who are actually looking for the placements. And we have got all covered in your machine learning AI program as well. And yep, I guess we have everything set up in the ML Study Jam. So without any further delay, I would like to invite Pranav, co-organizer of ML Study Jam and community manager at Nashik.
Hello, Ketan. So
Hey,
I
Pranav.
just came previously. So
Yes.
hello, everyone. So we are here for the first day of ML Study Jam, and I have a couple of announcements for you guys. So we are going to cover all the topics in machine learning, ranging from deep learning to a native machine learning to time series, computer vision. So many interesting things we have planned for you around the whole month. So every weekend, like Saturdays or Sundays, we will host such sessions. And yeah, so the first session today is going to be conducted by Vedarth, who is going to talk about introduction to machine learning, how does machine learning actually work, and everything. I'll just give it to Vedant now, and I and Ketan will go off stage. Catch you guys. So yeah, we have Vedarth here. Hello, Vedarth. Now I will hand over to you. Bye bye.
Hello. Thank you, Pranav and Ketan. So, hello everyone. Again, good evening and a warm welcome to our very first session in our ML Study Jam, which is organized by ML Community Nashik. So, are you ready? So, we'll make this session interactive. So, whenever I will ask questions or anything you want to say, please do use chat box so we can make it an interactive session. So, let's move on. I will just share my PPT. Just a second. Okay. So is the PPT visible? Can I please get thumbs up? Okay. So, bit of introduction to myself. Myself, Vedarth Khandve. I am currently AI and DS undergrad at Kekewa College. Apart from that, I am AI and ML enthusiast like all of you. Uh, Speaking about my technical skills, I have multi-cloud certifications, including one Microsoft Azure Data Scientist Associate, one is Oracle JNI Professional Certificate, and another is like GitHub Foundation Certificate. So, without further ado, let's move on to our fantastic session. Yes. So, our very first question, like, what is machine learning? So, basically, this is a fundamental question, and it is actually asked everywhere. So, I want to hear from you guys first. Can you please define or say what is machine learning in your own language? No problem at all. Uh, okay, I guess there is some lag. So let's move forward. I will introduce you to machine learning first, and we will interact at the end of the session. So the first, we can say, technical term of machine learning was introduced by Tom Michel, and it actually says a computer program is said to learn from experiment E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. So I am 100% sure बहुत कम लोगों को समझा होगा ये. In the first attempt even I don't understand it. It just went from my head. So, without explaining you the meaning of this, I think I should go forward and explain you simple terms. So, this simple sentence was coined by Arthur Samuel, which was the first technical term in this ML field. It was coined in 1959, and it says ML is the field of study that gives computers the ability to learn without being explicitly programmed. So we can say like to train your machine learning model to learn from its experience. As simple as that. Okay. Are you guys with me? Just give thumbs up. So I get we are on the same page. Okay. So this is me, Malat. So for the people who says I don't like statistics, I don't like maths, but for them it's actually bad news. But ML includes algorithm plus statistics at its best. So don't just ignore maths and statistics because they are the fundamentals or the root we can say to make a ML model in the future. Okay, so this is a subset. Like we are often get confused between what is ML, AI, and DL to be precise. And this is actually asked in into the questions also. So let me make it clear for you guys. So AI, it is a broad term, and we can say an artificial system which can depict human behaviors and function according to it. Then we get a subset of ML, which is under AI. ML, as defined previously, it is algorithm whose performance are actually increased as its experience is increased. Okay, and to explain you ML in short terms, what do we need? We need a data set. We need a data source probably. The data should be correct. It should be clean or it should be processed. We don't actually get data in our desired format. Actually, we need to apply processing techniques on it. Another point for ML model, what we need is computation power. So I guess you must have heard in recent news, which is actually trending, and one of the best companies in the world at top ranking one is Nvidia. So they have recently launched various of computational GPUs, CPUs, and they are actually into making AI accessible to everyone. So interesting fact is they are looking forward to make the computational powered CPUs and GPUs available at cheaper cost so that it is accessible to us and more common people. So actually it is a great initiative. Apart from that, we have deep learning coming again to our subset portion. So deep learning consists of, we can say, ANN, CNN, more neural networks concepts, which are trained on large data sets. For a detailed introduction of deep learning, we have a separate session schedule. Please do look out for it. So I will just move forward. Okay, so our basic question and one of the important question is types of machine learning. Uh, Actually, there are three types. There are three types: supervised learning, unsupervised learning, and reinforcement learning. There are also other types which are not which doesn't come actually in basic types, but they are there, like say, self-supervised learning and etc. So to explain you what is supervised learning. Supervised learning comes with labeled data. Always remember, supervised learning comes with labeled data. So now you might have a question like, what is labeled data? So labeled data, we can say it has a data which contains the parameters, which contains the features, which is associated with output. So if I am a computer, if I'm a model, for example, I get a data, so I get to see, okay, so this is the picture of a cat, and it is aligned to cat. This is the picture of a dog, so it is written dog. So likewise, this is a label data, and this is called supervised learning. In unsupervised learning, we don't have label data. It is more focused on finding the patterns in the data and predicting the output. It's like if you get pictures of cat and dogs mixed, so the computer will see, okay, so it will check on the different parameters like size. So if it's small in size, so it may be kitten or cat. If it has a long tail, so it can be dog. Likewise, last point is reinforcement learning. Reinforcement learning is mostly associated with your trial and error method, we can say, reward and penalty in scientific terms. So in this learning, model trains itself when it actually predicts the correct it gets a reward, and when does it actually predict false values, it gets penalty. So likewise, he learns automatically. To explain this you in more detailed format, I will show you this pictures. So here we can see in supervised learning we have label data, like I already said. So a computer is being trained like this is apple. So whenever he says banana, it actually the person says no, it is not a banana. And when he says apple, he says yes. So the computer learns itself like, okay, yeah, this is apple and this is banana. In unsupervised learning, like I previously gave example of cats and dogs, here he actually segregates like what are the apples, what are the bananas, and what are the fruits. And he actually doesn't know what are the rights, but according to the features available, according to the patterns he observes, he separates the data. Okay, and then we have reinforcement learning. As you can see in the meme, it says positive or negative learning, then that's 100% reinforcement learning. So what actually is positive or negative learning? So basically, whenever your model gets correct value, like I said, he gets reward. That is positive learning. And whenever your model gets true false values, or then it is said negative learning. Okay. So I hope you guys have got a thorough understanding of types of machine learning. They are the basics and they are asked frequently. So if you have any doubts, please do mention in the chat box. We will try to reach out. Okay. So quick questions for you all. Uh, can you please identify what are the categories this can be uh, divided, like in what categories it comes, like supervised, unsupervised, or reinforcement learning? I guess, okay, I will wait here for 2 to 3 seconds if you want. Please comment in the chat box. So what is the answer of anomaly detection, fraud? Okay, can you guess? Okay. Okay, correct. I guess Vibo says it is unsupervised learning. And what about others? What is email spam detection? Email spam detection. Okay, yes. Rishikesh says it's supervised learning. Correct. And what about game playing? This might be tricky sometimes. So game playing like chess, we can say we need to learn ourselves step by step. Okay, so game playing actually comes in reinforcement learning. And what is the last one? Sentiment analysis on social media. Uh, I guess it is common, so everyone can answer it. It will be supervised learning, obviously. Okay. So let's move forward. What are the applications of machine learning? So yeah. So what are the applications of machine learning? Basically, machine learning is not to be termed in small sentences, I can say. It is actually applicable in each and every industry in this century and also in this decade, actually. In 2 to 3 years only, there is a rapid improvement in the usage of ML and AI. So, yeah, as you can see, machine learning is everywhere. Wherever you see, there might be an application of ML. Whether or not ML has actually introduced in each and every industry, but there is still some time to grow. So let's move forward. So ML is not just theoretical; it is actually changing the real game of the world. So there are few of the coolest applications which we usually see in a day-to-day life. So we have automatic language translation. Uh, they are mostly associated with LLMs and higher computational models. Then we have medical diagnosis. Now, talking about medical diagnosis, there is a recent news. I think you might have heard it, which was in Japan. I guess Sony. Yes, Sony introduced their machine learning model robot, which is specialized in microsurgery, like stitching the blood clots and etc. So this is actually a drastic improvement in the medical field also. Apart from that, we have stock market trading, which is also this associated is also there with stock market trading, but it is still in the booming sector. Then we have online fraud detection. This is also an important point, like we already discussed. Then actually online fraud detection also comes in supervised and unsupervised learning. Okay, because it can find patterns, and at the starting it is learned with the label data. Okay, I guess you have some. There was some mixture of answers. Then we have virtual personal assistants. So virtual personal assistants we actually see actually in our day-to-day life. We can see Siri and Alexa, and they are actually trained on high-level model computational resources also. Apart from that, we have email spam and malware filtering, which is has an tremendous application in today's world because most email and Gmail are widely used applications. Then we have self-driving cars. Self-driving cars also has uh, been learning on reinforcement learning. Actually, whenever self-driving car or other applications are concerned, uh, there might be not only a single learning method. So starting they can be semi-supervised, which is mixture of supervised learning and supervised learning, and also reinforcement learning. So the model can train iteratively. Then an interesting domain where ML has already taken its step is product recommendation. We can see Amazon is already using it. Amazon, Flipkarts are actually pro player in this segment. Then we have traffic prediction, one of the global problems in this decade. Also, we have traffic problems. So ML can actually find the real life solutions to these problems. Then we have speech recognition, which is also important in various sectors, including the specially able sectors where they are cannot speak in or they need an assistance in speaking abilities. Okay. Then we have image recognition, and we all know there is no field where image can't be used. Okay. Another important point is okay. We will move on forward. I will again come back afterwards. Okay. So you might think like, uh, yeah. So we get to know like this is the functionality of model. This is the application of model. But how do models actually work? So it is an important point, and so let's dive into it. Is everyone with me? Okay. Okay, sure. So first, there are approximately 5 steps. First is data collection. Then we have data pre-processing. In data collection, we actually are concerned with the collection of data from where data source is collected and how are the parameters which we want in our data. Okay. Then we have pre-processing. In pre-processing is associated with the cleaning and transformation of data mostly. It is also an important step. People usually neglect it, but it is duly important. Why? Because if just make a scenario, if your model is trained on unprocessed data, which might contain noise is like we can say outliers in data. So what will happen when your model is trained on that data? The output it's give will be faulty, and its accuracy will be low. So it's duly important to highlight this step number 2, that is data pre-processing, because when we actually go move forward, step 3 and step 4, it's become hard to again come back and then pre-process our data. Okay. Then we have model selection. It is also related to the concept, or what do you expect from the model in at the output. What is the application you want to build from the model. Then we have training the model. Training the model, we use actually fit function method. Training is associated with making your model learn from the data. Okay, we give data the input and we give data the output. So the model is learned on these two factors, and then whenever we ask questions to the model or give another input, then the model correctly predicts the output. So this is, we can say, training the model. In technical terms, we say it is inferencing concept. uh, and the last step is evaluation and fine tuning. Evaluation and fine tuning is also one of the important step. Why? Actually, we will see in the code itself. So let's move to the code. Just a second. Okay. So this is Colab. I think most of you might have used it till now. It is by Google Colab. There is also another option. We have Jupyter Lab. I usually prefer Colab. Uh, for those who are beginners, they can try running their code here. We actually get the computational power in here itself. Uh, okay, so if you have data, you can just, I will just explain you the steps how to upload the data. You can go here, files, this drop down menu, then click on upload and select the file which you want to upload. Okay, once you upload a file, there are also other sample data also available from which you can practice your ML models. Then just click here and copy the path, and once you copy the path, see, I've copied the path here, and your data gets into the model. Okay, so what is the step 1 which I've already checked in a PPT is data collection. So these are the few steps which are required. So we import pandas as PD. Pandas is a library, and uh, to explain you the pandas in detail, we actually have another session tomorrow which is to be held. It is solely focused on pandas, so you can check it out there. Moving forward, I just imported my file in this path. Then I used pd.read csv, which is available due to pandas. Then whatever the data I have, it is stored in this data frame. It is home data. Okay. So I just printed the data. So this is how our data technically looks. There are various parameters, columns, rows in this data. Okay, so there here we can see 1260 rows into 81 columns. So this is our total data set. Okay, so step number 2 is data pre-processing. Like I said, it's an important step. So to explain you, I have used this function. So first, we will just print home data dot is null value, and we'll count the data where the data we will count the rows where the data consists of null values. Okay, so there are like this. So you can see lot frontage can has 259 null values. Okay, so what I've done to remove the null values is I have used the home data drop na function. Okay, which is available from the pandas itself. So what does it do? The drop na, it actually drops all the null values in your data. So your data actually gets pre-processed. Then I've just printed the null values again to check if there are any null values present in my data set. So as you can see, first I have 259 null values for lot frontage, and once I use drop na function, now there are no null values in my data. Okay. Moving forward, I actually print columns in my data. So as you can see, there are a number of columns. Now an important concept which is of features. So I guess most of you might have already worked on it, and you might have known what are the features. So we can say features are the columns through which our output is dependent on them. Okay. So my model, if I'm training my model on certain parameters or certain features, so I have to select that columns from the data which are actually resulting in my output. I don't want to use another columns which are of less importance or will just increase my computational power and latency. Okay. So to give you a task, can you please mention some of the columns which will be useful for a data set? So to just give a rough idea, this data set is of house data prediction model. So just comment in the chat box which features you think will be useful for our model to predict the pricing. Okay. Okay. So there are a number of columns. You just check it and give the name of the column you think you might which might be important for a model. Okay. So first is ID, then other factors: lot frontage, lot area, street, land counter, conditions, neighborhood. So I have actually selected number of ones, but I think you should try it. So can you please comment in the chat box? Okay, I guess it will take time sometime. So I think, okay, see, I have selected here. So they are mostly a lot area, which is in the square feet. Then we have year build, in which model, in which year the building or the house was built. Then first floor square foot, second floor square foot, full bathroom is there or not. Then bedroom above garage, and this is also total rooms above the garage. Okay. So to sum up, this is actually a supervised learning where we have given two parameters, two variables. First is x and second is y. Let's come to x first. So x contains all these features which I said you, which are important for a model to predict the output. Okay. And what does y contains? Y contains the output, which is given in the dataset itself. So what we will do, we will train our model on this x data, which contains these features, which actually we see, and then we will cross check it with y variable. So if our predicted values and actual values are correct or not. Okay. So I have used the describe function and the head function to describe what is in the data itself. So when you use the describe function, you get the metrics such as count, mean, standard deviation, mean value, max value, and 25%, 50%, 75%. Okay, so for those who don't know, mean, max, 25, 50, and 75 are actually associated with the quartile deviation concept in statistics. Also, remember this can be used for your box plot in future. No need to go in details. So, step 3, coming back to our steps, which is model selection. So we have used decision tree from the XLM module framework, and the basic syntax is I have used the here the name, and which is decision tree regressor, and in the bracket I have used random state. So what does random state is? It is actually associated with the randomness in your data. So when we select the data, so to get the same result in multiple when we run the code multiple times to get the same data, we use random state. Step 4 is training the model. Training the model is just simple. You just need to use the fit function. So in basic level, so what I've done, my name of the model dot fit in bracket x and y, my two variables. X contains my features and y contains my expected output. Okay. So after this, I have used dot predict function to predict the values from my model. And as you can see, here we have around 22 lakhs, 2 lakh 8,000 something values. So to actually check what is the predicted values and what are the observed values. So we can see here the in sample prediction are 20. You can see in there in this array, and then we have the actual values which is derived from the y. We can see, so first is the predict values which I predicted from the model itself, and second one is the values which were actually in the model. Okay, so you can see they are nearly same. Okay, so 2085000, we can see that data is actually same, but uh, we will get to know it is correct or not in coming steps. So next we have step 5, evaluation and fine tuning. Mostly even evaluation fine tuning step is neglected by most of the professionals because it actually takes time, but it is duly important. Why? Let's move check it. So to check if my model predicts the correct values, I have used the mean absolute error function. So what it does is actually calculates the MAE error from between two variables. One is my y, which contains my actual y values, output values, and second one is the predicted home prices, which I have used from the model. So as you can see, when we print the MAE, it actually is 62.35 something. So 62 is actually low. So we actually get happy, like, yeah, my model actually have only 62 mean absolute error. But wait, this is not the scenario. Uh, Before going forward, let's go to our model first. So here we can see why model validation is important. uh, what is actually model validation? It actually checks if your model is accurate to our expectations. Okay, just as simple as that. So here you can see in this code I have used one concept of train test split method. Okay, so what actually does train test split method do? So I will just explain you from the whiteboard itself. Just a second. Okay, so just imagine you have a set of data. Okay, train test split method is used when we want to split our data into two halves. One is the training part and another is the testing part. So if we can divide it into two halves, mostly and in standardized format it is 80% on one side. Yes, for a second. 80% on one side, and on another side it is 20%. But you can actually change it around 70 to 30% also. So here, what actually is 80%, 20%? 80% is your training data, and 20% is your testing data. So what happens when we divide our data into this format? Let's check in. Uh, just confirm if you are with me. Okay, just give thumbs up. So I think all are with me. Okay. Okay. Till then, let's use the train test split method. So how it is used usually? It's very simple, nothing rocket science in it. From sklearn model selection framework, you import train test split method, where the basic syntax is train x val x. So what is val actually? It is validation x. Okay, then train y and validation of y is equals to train test split method x y, which are our original variables which we have already described in our above, and then is random state. It is up to you if you want to set the random state or not. Okay. uh, Next one. So what I did, so this is a new model. What I did is I splitted my data into two halves. First is training and second is testing. Okay, so I want to now train my data on this model. So I have used the decision tree regressor random state one in this model, and I've again used the fit method to train it. And now I didn't use x and y. You can see here. What I actually use is train x and train y. So I am now training the model, right? So I will use the training data only. So training the train x and train y associated, and val x at validation data set of x and validation data set of y will be used for testing. So I have tested my model decision tree regressor, and afterwards I use the dot predict function to predict the values of my model. Okay. So this is just a printing function, just as simple. I have used till only 5 values. So these are the values which my model predicted after I have used train test split method. Okay. Now you can see here, I have also printed the values of my y. Okay. So which were originally there. So the printed value is 231,500 and so on. So now it is actually clear our predicted values and the actual values are different. Okay. So to calculate what is the actual absolute difference, so to be more precise, we used again mean absolute error method, wherein I have used the value y, that is our validation data set of y, and then value of prediction which we used from the model, and I've just printed it. So my mean absolute error goes up to 29652. So what we actually see up like 62 and so, and it is actually not true. Why? So whenever you get question like why is my error so less when I used my same data to predict my values, and why it is different when I use train test split method. So when you use same data to train the model and same data to test the model, we get a very low value, and it is called as in sample prediction. These are statistical terms to be remembered, in sample prediction. But in real world circumstances, we use train test based method. So what it does, your model is trained on the training data, and the model doesn't know what is in the testing data. So once your model is trained, we just feed your model the testing data, and it gives output. So that time we get to know like what is the accuracy of my model, and that is important. Okay. So now I think you might have got why model validation is so important. Okay. So as you can see, this usually happens in corporate sectors when we put the model in production without testing on validation data set. So actually they are laughing to tell you whenever companies associated with building of application, they works in two categories. One is development and second is prod, that is production. So it is prod is directly available to users. So you should always validate your model before you give it to the production. Okay. And in case just for mistake you just upload your model without in production without the validation, what happens is this model is deployed and boom, you will get fired the next day. Okay. So coming next to our topic, just confirm like we are again together. Okay. So I get confirmation. Okay. So our next topic is underfitting and overfitting. Now some of might have actually heard these concepts before, and some of might have not. To just summarize it, they are important concepts in the field of ML. So what is ML underfitting? Underfitting is we can say a very simple basic model. It doesn't have too complicated data and too complicated tasks to be performed. So when it is the model actually is trained and it is a simple model, we don't actually get the values which we expect from the model. Okay, this is called as underfitting. And second one is overfitting. Overfitting, we can say when your model is trained on large data sets and actually it is trained heavily. So what happens is like uh, you can say ratta maar, okay, in our professional language. So वहाँ क्या होता है कि for example if there is concept and I just do ratta of the concept. So what I do, I actually not getting the meaning of the data. So if there is any mistake in the data, we also learn it and write the same in the examinations, and hence we get the low marks. So in moral of the story, don't do ratta. Learn from the meaning itself. So this is similar to overfitting, what I actually mean to say. And you can see in the graph itself, on y-axis we have mean absolute error, and on x-axis we have t-depth. So we will actually see what is t-depth in next slide. So whenever your model is in underfitting category, its mean absolute error goes on decreasing. Okay, as you train your model continuously, the error gets decreased, but after some time your error actually increases. Okay, so it is not a continuous step, but so it gradually slows down, and after some saturated point, so we can see given by the symbol, after that points overfitting comes in the picture, and when overfitting comes in the picture, the error again starts to increase. So this is an important concept. So how to find out the accurate precise value to where the mean absolute error is the minimum. Okay, so that is our fundamental question. So let's move on again to our code so that you will get a thorough understanding. Okay, so before that I will just explain you with what is decision tree. Basically, just a second. Consider this as your root node. Okay, I guess most of you might have heard about the trees in colleges. So at the topmost level we have root node, then we have a number of branches. Okay, and at the last we have what we call leaf nodes. Okay, leaf node are the lowest level in the tree, and they actually contains the output of the model. So what is basically a decision tree? It is like this only. I will just explain just a second. So your root contains a condition. Okay, for example, we say take the example of house prediction only. So we might say what are the rooms. So yeah, actually each node means the root node and the branches contains a condition to be satisfied. So if there is some condition and it is satisfied, if it is yes, then it goes under this category. If it is no, then it goes under this category. Okay, and what does the branch node contains? They actually contains the same conditions only. So if, for example, I have greater than or equal to 2. Okay. So if my rooms in my housing data set, if my house contains more than 2 rooms, yes, there are 2 possibilities, either yes or either no. So if yes, this is the output. If no, then this is the output. Similarly for this part. So this is actually how a decision tree works. This is for a leaf node for clarifications, and these are branch node. Okay, so what you actually do in decision tree regressor is you give a condition. If it is yes, no, accordingly we moved deep in it. Okay, coming back to our code. Okay, it is disconnected. So what I have done to just don't forget, we actually heard about underfitting and overfitting, right? So that's why I'm explaining you this. So I have made a function which is get ME, get mean absolute error function, as you can see here. It consists of some parameters, which is max leaf nodes. So what are leaf nodes? Like this bottommost nodes. So I have for one node I have 4 leaf nodes. Okay. So here I used get ME function, and here I have max leaf nodes, train x, value x, train y, and value y. So I have used the train test split method only, and the inner steps are same. I have trained the model, I have predicted the model, and printed it. Okay, the error. So I actually give model a few of the values for max leaf node, which is 5, 25, 50, 100, 250, and 500. So what my model will do, you can see here, it will calculate the score. And how? So it will, on one side it will take leaf size, which is you can see here 525 here, and associated ME, associated error with your leaf nodes. So this is the basic function, and I've just printed it, not rocket science something. So you can see for 5 I have ME of 35,000. For 25, so it gets decreases until 27,283, when my nodes are 100, and when I increase again my nodes to 5,500, the error again increases. So as you can see, this is similar to our graph which we see here. So it gets low up to 27,000 and then increases. So we have to find this. So from this function, I actually found out that at my leaf nodes 100, I get the minimum error. So this is how you actually use the interfitting overfitting concept to make your model optimal in optimal condition. Okay, so I guess we are mostly towards the end. So if you have any questions in the code itself or any other question, please do comment in the chat box. We are short on time, so let's move forward. Okay, so another important concept is ML trends to watch. There are few trending concepts which are really buzzwords in these days. One is definitely Gen AI. You will 100% sure see hear this everywhere. So what is Gen AI? It is mostly associated with the content creation part. When your AI model is trained to create the content on its own. On an interesting note, जिसको पता नहीं होगा या फिर you might have know it, when in around 5 to 6 years before, when there were no traces of AI and ML in India also, scientists predicted that whenever AI and ML will come, they won't take the jobs of creative industries, like we can say creating posters, editing videos. Why? Because it needs human intelligence. Okay, so this was the hypothesis mentioned around 5 6 years before. But as soon as the Gen AI was came into the picture, it actually neglected the hypothesis. And as we can see today, Gen AI, we can say Mid Journey, and their contents which they create are actually fantastic. Recently, I saw a picture of Will Smith hugging his younger self. So that's the capability of Gen AI. Then we have LLMs. These are the trending word. Large language models. These are associated with training your model with billions of parameters. Sorry, not billions only, trillions of parameters also. Llamas are Langchains are actually trained on that parameters. Apart from that, there is interesting concept which I guess most of us might not be accustomed to it. That is SLMs. That is small language model. What is this? They are actually trained on lower parameters than LLMs, but their efficiency is at par to them. So we can say if I want to use LLMs in our basic systems, my computer or my phone. So in coming future days, we actually see SLM doing the job. Apart from that, we have explainable AI. Explainable AI is associated with the AI ethics part, where you actually get a constant where AI tells you what is the functionality of AI, how does it calculate the and predict the output. So in medical industry, when I say give the example of the microsurgery part, I want to trust the system. So AI should be reliable. Like I won't trust an AI just to operate on my body. Okay. So they also we have AI ethics session coming in our series. So stay tuned for it. Apart from that, I have to share 2 to 3 points here. There are also cloud certifications associated with this ML, which is actually trending nowadays, which includes major cloud providers also, Azure, GCP, and AWS leading the race. Also, there is also a chance where your company deploys your model in the cloud. In coming days, it will surely be on the cloud itself because of number of advantageous cloud providers. And okay, so now most of you might have think, yeah, I got the rough understanding of MLs and how a model is trained, what is the advantages. So, but our fundamental question like, मैं शुरू कैसे करूँ, right? We always get stuck on the action part. I am not able to get on the action part. So for you guys, even if you are a beginner or you are intermediate level in your ML journey, we have something which you will actually like, and which is Kaggle. It is a treasure trove for all machine learning enthusiasts. Even if you are beginner, they have competitions, data sets, they have specified learning paths from where you can actually kickstart your journey and you can become pro someday. So just to this is a screenshot. So as you can see, when you just sign in or open your Kaggle website, you can see there is home, there competition button. In competition, you can see that current competitions in ML feed which are held. you can participate in, you can contribute in, or you can just check it. What are the models the winners made? Then we have data sets. Kaggle has huge amount of data sets available. You can just play with the data sets. Then your models, but Kaggle also provides interface for your code, and then is the discussion forums and learn. So learn actually where you get specified paths. So here you can see there is, if new to Kaggle, they says this competition are perfect for newcomers. So they are just curated the competitions, like these are easy to begin with, and these are this requires pro level of understanding. Also, once you sign into your Kaggle, you can also see the active competitions, the closed one, the pinned one, and the hosted one. So if I host some competition, I will get there. That's it. Please start learning, and Kaggle is an easy way to start your journey in ML. Okay, so I guess we are at the end of the session. Thank you for joining us today. Keep in mind, your journey in ML is a marathon, not a sprint. Go slow and steady. And also, uh, there is a fundamental question which is asked in everywhere, in every session, I guess I will say. That is, will AI take my job? Okay. So the one simple and basic answer is AI won't take your job, but the person using AI will take your job. Okay. So start using AI ML for your personal projects also. Start learning ML. There is fantastic job opportunities with high paying salaries at comparative to other domains. And yes, that's it. Keep experimenting, keep learning, and most of all, have fun. Okay. If you have any questions, we are there in the chat box. Please do uh, ask the question in the chat box.
Uh, yeah, I was mute. So hello, Vedartha.
Yes.
Yeah, it was a really amazing session. If you guys have any question for Vedanth, you can ask them in the chat. We will together try to answer it. No worries with that. We'll just wait for some more minutes because we have somewhat
Yeah.
10 minutes more left for
Yes.
our session.
Even I
Yeah,
have something to say. Actually, I forgot it. How
yeah.
many of the participants actually watch anime? It is very interesting question. Like nowadays, oh,
I watch.
Pranay
I
itself.
watch.
Oh,
Yeah.
great. So actually, even I am a anime fan, and around 2 years ago, I don't know anime. I just regarded it as cartoon only. So what happened in future? My friend suggested me to watch Demon Slayer, and from that point onwards, whenever I completed one anime, the website actually recommended me next anime, right? And you will don't trust actually trust me, the recommendation of the site is fantastic, and I just got addicted to animes. So this is an real life what we guess example of ML in our surrounding, but also it's addicting, so make good use of AI.
Yeah, yeah, it's completely true. I'm still stuck with One Piece, so if once I
Oh,
finish that, someday I'll watch it. what is
yeah.
what is it? Don't okay, Rishikesh doesn't like that much. It depends on everyone. We have one question: how to overcome underfitted model? So
uh, okay, so when you have underfitted model, actually it actually depends on your task. What is your expectations from the model? If you want to make a complicated or a complex model, actually making a complicated model is not a bad thing. It is actually good when you want to use a model for complicated task. Then to remove the underfitted part, use more parameters. Okay, so
yeah,
that your model overcomes the simplicity part, and it actually get trained on other parameters also. So when you give testing data set to your model, it gives you correct answer. So I guess that might answer your question. And if
I
Pranav,
will. I will like to add upon that.
yes, yes,
So
sure, sure,
there are three types. One is underfitted model, one is a good fit, and one is overfit. Right.
correct.
So for underfitted model, the answer will be train more. Train your model more. Maybe you will reach the good fit. So
Correct.
you can identify your underfitted model with uh, it has low accuracy and low bias too. You have to check the evaluation metrics for that. So
Yes.
without mentioned one, that's mean absolute
Me absolute
error.
errors.
Yeah, you can
Actually,
have a
there
look
are
at them.
many more metrics also. So do check it out once.
Is reinforcement only limited to negative or positive, or there is much? I just framed that.
Okay. It is.
Uh,
Actually, yes.
yeah, you
Continue.
can go.
Continue.
It's based on a reward system, so it's not positive or negative. The reward reduces or decreases, so that's what is meant by negative or positive over there. So if you do a good task, your reward will increase. If you take the example of chase, so if you do a good move, your reward will keep on increasing, and the AI will understand, okay, I have to increase the reward. And if you make a bad move, make a blunder, your rewards are absolutely going to decrease. So that's the negative thing.
So in technical terms, it is actually termed as penalties and awards, as Pranav correctly said.
Yeah, that's penalty, the word I was missing. Thanks for that.
No worries.
For a predictive model, what is good best percent range?
Predictive model. What is the good best percent range? So do you mean by accuracy or what? Vaibhav?
I think he's talking about accuracy.
Accuracy, no?
Yeah.
Actually, so fundamentally, the higher your accuracy, the more better your model. No contradiction to that. But practically, going above 90% is tough part. So if you achieve some, it's good.
Uh, yeah, and in the industry, no one actually looks at your accuracy. There are some other metrics too, that is root mean square error, or they we will talk about confusion metrics too in the
Correct.
future sessions. So that's what people look upon. It's not all based on accuracy.
Yeah. And the confusion model also consists of recall and precision metrics, which are
Yeah,
actually important.
so
So we will
there
cover that.
that
Yes.
we'll absolutely do that. Uh, but if more accuracy, it goes overfit, right? Yeah. Uh, are you
Uh,
guys? I think they are a bit confused about underfit, good fit, and
huh,
overfit.
even I think so.
Maybe I'll share my screen and try to explain because I see some more minutes. Let me just see if I can do that. Hmm.
Yes, yes. Sure.
Let me check if uh, I'm on my correct screen, or I'll share something else which I don't want to be on live. Yeah.
Okay. So just answer you till then, Vaibhav. When you think your accuracy is too high and you are have fear about if my model might go under fit category, so you can check it by giving your model a new test data. So if your model performs well on it, so your model is actually good. And if it gives a random value and less prediction, then you can go for the or you can confirm that your model is under fit category.
I will draw a data set to explain you guys.
Yeah, yeah.
So let's take something like this. So these are the data points which I want to predict. Fine. I'll just move fast. So if my model prediction line is this, and these are the points which I wanted to predict. Fine. So this is a underfit model. How do I text that over here? Uh, this one is underfit. Fine. And if the prediction line of my model goes something like this, it means it has actually learned the data set. So this one is a overfit model, because it is like going to each point, and if I give a new data set which is somewhere here or there, it will give a low accuracy score, and the best fit will be something between all these points. So this is the bias variance trade-off. which we are going to talk about in the future sessions. For now, you just understand this one is the underfit line, this one is the overfit line, and this one is the good fit line.
Good fit. Correct.
Awesome.
Rishikesh, for reinforcement learning and all, we have a separate session in our series. Look out for it. Okay.
Can you tell in deep about reinforcements? Yeah. Today's session was just introduction to machine learning. So how do you expect us to tell about reinforcement learning? I'm unable to understand.
Yeah, we have session in our plan, so do check out for it.
Rishikesh was unable to understand. Okay, Rishikesh, I'll make sure that these concepts are made clear in the intermediate machine learning session, which is going to be held by Vedant. So maybe he'll answer that questions. Just stay tuned with us, because today we just did an introduction to machine learning, so we didn't talk about of the concept in very brief. Okay, I think we can end the stream and we don't have any questions. Mm. Okay, how many of you are still watching? Just drop a hi.
Yeah, so we can get a
Oh,
count.
yeah, because LinkedIn doesn't show actually what how many people are
Viewers.
currently watching in the audience. That feature just disappeared. I don't know why. So maybe you guys can just drop a hi quickly, real quick, and we'll just end the session.
Also, feel free to connect with us on landing also. Okay.
Thank you. Thank you. Oh,
Thank
okay.
you.
Okay.
Thank you,
Oh,
Rian. We have
welcome.
Rian with ourselves.
Yeah. And yeah, we have Ketan, our community manager. We have Arya. Hi, Arya.
Hello.
Hello, hi. We have one of our future speakers too. So Madhura will be delivering a talk on computer vision. She is here too. Uh, yeah. We have Nitin. Hi, Nitin.
Hello, guys. Okay.
Okay.
Even if you have any doubts, connect with us and also our organizers. We will surely help you. Okay.
Yeah. Uh, okay, then I'll just end the stream. Uh, See you guys later. Bye bye. Bye, Vedant.
Bye. It was nice meeting with you all.
Yeah, it was nice having you from, and thanks from the machine learning Nashik community for delivering such a wonderful talk over here and addressing the doubts of attendees too. Thank you.
Thank you. It was my pleasure.
Yeah. Bye bye. Now
Bye.
we'll leave for you.
Yes.